Hello there, everybody. Well, welcome to part 3 of our Carver Silver 9T video series. And this is amplifier number 2. Amplifier number 1 we kind of set aside. And as you saw, it works, except it distorts way before it gets to its maximum output power. So all I've done right now is I haven't touched this one. I basically set it on the bench, plugged it in, turned it on so it could warm up a little bit, connected the same dummy load, the same same equivalent test setup. Signal generator is on, and I have my scope connected so that we can look at it, and we're just going to kind of monitor what's going on here. Now, I do not have this set to put out full power, but it should drive this thing to 200 or 300 watts. I mean, it's not going to drive it to 575, but I'm only putting about 2.5 volts RMS at 2 kilohertz into the input. So we'll see what kind of output we get. So at 2.5 volts RMS, 2 kilohertz, here's our watt meter, and the bottom part of the meter shows dBW, so dB based on 1 watt, but that's kind of, I think that is kind of a little bit misleading. I'm not sure, because that would mean 0 dB would be 1 watt, and I do not believe this meter is working that way. The next one up is dB, which is this scale, and this 0 dB, which is this graticule right here, they're saying is 575 watts. So this is the actual scale that we're going to read. I don't really know the purpose of these other scales. I didn't read up on it yet. But 0 dB is 575 watts. And if you look at the instructions when you do the calibration for the meter circuit, that's what you're concerned with, is this scale right up here. So you know, if you're at 0, that's your 575. So if we're down in here, that's going to be, you know, a good bit less. You know, if we're 3 dB down, it's like, what is that, half, I believe. This will be 10%, I think. Probably misspeaking because I didn't look it up. But anyways, let's turn this on and see what kind of output we get. And you can see we're about -4 dB, and I'm going to turn that off, and I want you to see what's going on the oscilloscope while we do this. And as you can see, we're getting unsymmetrical clipping once again, but you're not getting the weird soft clip at the bottom, that weird curvature. It's just clipping non-symmetrically. And if you noticed, we were getting somewhere around 50 volts RMS, which is somewhere in the 300 to 315 watt range, I believe. So, yeah, 312.5 watts. So around 315 watts roughly, and which is way below maximum power. Again, I have this amplifier directly plugged into the outlet, and I will say the outlet that we're plugged into is number 12 gauge solid copper wire, and it goes straight from the outlets there straight back to a dedicated 20 amp 120 volt breaker in my breaker panel, in the mains panel, which is just across the basement here from where I am. So that's about as good as it's going to get, short of directly wiring it to my breaker. And so I don't know if that's, again, this is straight out of the box. I mean, I haven't touched this, I haven't taken a cover off, I've done nothing. And that's where we are. So obviously, and if we turn the power down on this, so let's go down to 2 volts RMS input, and you could see right there at 41 volts, you can see these little tick marks here showing up. I don't know if the camera's picking it up or not, and you can see just a little bit of noise right up here. So let's say 41 volts. So at 210 watts, this one's working pretty clean. I don't have the distortion meter connected right now, but at 210 watts, it's visually pretty clean on the scope. But as soon as we get up to that 300 watt range, it's some pretty severe distortion. So again, my question is, this is an untouched amplifier. Does that mean this one has a flaw in it also? Or does it mean that my incoming power in the shop here is just entirely inadequate to run these amps properly? I don't know. For both amplifiers to have the exact same problem the exact same way, that would be kind of a strange coincidence. So I'm leaning towards, you must really have to have some incredible kind of power. Again, I don't think this amp has ever been touched. I don't know. We'll take the covers off and see if this one's been serviced or not. I can tell you firsthand that other one was never serviced. It looked like nobody ever touched it from the factory. So I don't know. I don't know what to think. Don't know what to think. So I'm going to pull the covers off of this one, and we're just going to take a few measurements, and we're going to kind of compare them to what we were seeing on the first amplifier that we were looking at, and kind of see if this is acting in a similar manner. Again, nothing's been touched on the alignment for this. It's still however it was when I received it. None of the covers have been off since I received this. Nothing. It's just, this is how it came. So do we have two bad amplifiers here, or do we have just not the proper situation to use this amplifier? I don't know. If that's the case, then I would caution anybody before they purchase one of these to make sure you have a good, strong power line, or this thing's not going to work for you, at least at high power levels. All right, let's check this out and get some covers off and take a look. Well, at least the first problem is going to be a lot easier to troubleshoot than on the last amplifier. I think I can see our issue right now. You may or may not at this point, but I'll show it to you. If you notice, this is just all brittle, this tie wrap, and it's broken, and it looks like this one's ready to break if it's not already broken. And this is just kind of laying here. It's not shorting anything, but if we get in here real close and look, do you see what I see? Yep, the ground lug to this particular capacitor is disconnected, and it just cracked off, probably just from and this, by the way, this amplifier was not shipped in the mail or anything, so it really didn't have any heavy rattling around. I just think that it just, over the years, it popped and came loose. So I'm going to fix this. I'm going to have to take this big wad of goop off of here, right here, and we'll fix some new zip ties on there, how they had it. If you notice, the type of, the brand of capacitors they used here and the brand that they used down here is different from the ones that they had on the other amp. These caps here, I notice, are 2200 at 100 volts. On the other amplifier, they were blue color. They were 2200 at 80 volts, I believe. I'm not sure what this was rated at. Should be the same. This one's 9000 at 125, so it's the same. This one's exactly the same ratings as the other one. So yeah, it looks like they did a little bit of change in components. The rest of the amp looks pretty much the same as the other one. So there you go. So let's get this fixed up and see if that solved our problem. Okay, that's much better. I replaced all 4 of those zip ties because they were so brittle that they would just crack and fall off if you pulled on them too hard. So I put some new ones on, put a whole new binding wire between the two terminals, tightened the screws that were really loose. All 4 of those were very loose, and then resoldered the ground lead to the center. The amp is turned on. It's been running for a few minutes now, so should be ready to test. And we're going to go back to our oscilloscope, and you're going to see for the first time with me, I have not tried this yet. I haven't put any signal to it to see if this is going to make any difference. We're starting out with 2 volts RMS, and let's see what it does. Okay, so far so good. That's very, very clean. All right, so let's go up to our 2.5 volts and see what it does. And look at that. All right, let's go to 3 volts RMS. This should be getting us close to maximum power now. And that's what, 62 volts. So we're very, very close to our 575 watts. 68 volts, 68.7 I think is what they're saying. So let's go to 3.2. We're just going to inch up on it. And there's 66. So that's almost 575 watts. And now you're just starting to get a little bit of clipping on the one side. There's 68, and we're right on 0 dB. So that was 575 watts, and you saw how clean that was. Very, very little distortion. Now they're saying if we go, I'm thinking around 3.5, pretty soon it's going to start clipping, and they're saying that if it's working properly, it should clip symmetrically. So let's see what it does. And it is. You can see the top's clipping and the bottom's clipping just a little tiny bit. And that's all I'm going to run right now, because again, you have to go pretty fast on this because it will blow the mainline fuse. So there's living proof that this amplifier can adjust itself and function on this incoming power line if it is set up right. So the other amplifier definitely has a problem, and I think we're really fortunate this thing failed the way that it did. Think about it. It had the same type of problem as the first amplifier, and if you recall from the last video I did, I said that I kind of suspect that the problem could be in the 118 volt commutator circuit, because until you really start bringing in high power, if you noticed on that other one, it didn't really distort. It didn't distort till the higher power rails started coming in. So rather than it being the output transistors, now it still could be a commutating transistor, but I really kind of doubt that, because the outputs don't really have a lot of gain on them. They're more like for current. It would probably be something either, like I said, the power rail itself is failing under load, or one of the driver transistors or something that drives the commutators is breaking up unsymmetrically. So the good thing is we now have a fully functioning amplifier here. This was an easy fix on this one. So we can actually take a few measurements and write them down, and then we can go back to our original amp and compare. So this is all really good news. The better news is, obviously, this amp is definitely capable of working as advertised. And that's why I said at the end of the last video, I can't really make a judgment on the design quality or anything of this, because it was the only amp I had worked on and serviced and really got to test like that as far as these Silver 9Ts are concerned. So that's kind of why I like to withhold judgment until I see something working the way it should. So, all right, maybe this is going to turn out to be a lot different than the first video and the second video. All right, let's move on. Okay, we're back on this first amplifier, and we're just kind of going through and checking some of the signals. And right now, up here is your 118 volt commutator, and down below is your negative 118 volt commutator. These sets right here are your 67 volt commutators, and they're all controlled by this circuitry down in here, all the way back here. You can see these networks that will bring these in as you increase power. Now, right now I have my oscilloscope connected to the collector of these ganged together transistors, and I'm not a big fan of this, but I'm sure there was some reason to put these capacities. Maybe it's the capacitance values of these transistors, or some sort of reason that component works better doubled up than just using a larger component. I don't know. Didn't really get into the design of that. But if we go onto these two collectors, the first thing I'm going to show you is what it looks like on the amplifier that works properly. And I'm also going to hold the microphone close to the amplifier so you can hear it. So you can actually hear what the amplifier sounds like. And you can look at the waveform. So here's the oscilloscope. And I'm going to turn the amp on and hold the microphone next to it, or turn the signal generator on, I'm sorry. And here we go. And you can see that's a pretty clean looking sine wave, and it tracks along with what the output of the amplifier is. And that's for your and I have enough drive signal in here that we actually can get you're actually getting into those 118 volt commutators. They're actually coming in pretty strong, maybe somewhere in the line of 300 watts output, which is not 575, not the max, but a good signal drive that's using all of the commutators. Now I'm going to move my oscilloscope probe over to the same test point of the amplifier that's not working properly, and we're going to do the same thing, and I want you to listen to this amplifier and look at the waveform. Here we go. Did you notice anything? Number one, the signal was somewhat distorted, especially the bottom part of that waveform. It was a lot flatter looking. And that's exactly what the output of the amplifier looks like. So this is really not a bias problem. It's something is misshaping this. And if you trace back in there, you can see there's some weird things going on causing this waveform to not look right. The other thing is this amplifier has a much lower gain. The reason that transformer was not buzzing and the high-pitched whine was not as loud was because the amplifier is literally putting out less power with the same exact drive signal going into it as the other amp. So let me just look at the power. Let's just look at the power meters so you can see what I'm talking about. Here's the good amp that's working properly with a 2.5 volt RMS signal input. And you can see how much power you've got right there. Okay? So this would represent 575 watts here. So we were right back here about 3 dB down. You do the math. That's a pretty good amount of power. Now we go over to here and turn this one on. Same signal, same everything. And you can see it is considerably less power. The other thing I notice is on this one, the regulation circuit for the triac flutters. It oscillates at a funny frequency. It can't seem to find where it wants to be. So I think there's a couple things here. I think the shape of that waveform is a problem, but I think it's also causing a problem with your feedback loop back to the the regulation circuit with that triac, and it's causing the triac to oscillate back and forth between a couple different levels. So if you leave this on long enough, it'll flutter. I mean, you'll hear like a brrrr on top of that buzz of the magnetic field transformer. I don't know if I can get it to do it, but let's see if we can hear it. Did you hear it? And did you notice as that happened, the little light over the bench flickered? Let's see if I can get it to do it again. See it? I don't know if the camera's picking it up because it's happening so fast, but it's actually causing the lights on the bench to flicker with it because it's pulling current and then dropping very quickly. That brrrr sound, that's what's going on. So we have a couple problems in here, and I really don't, at this point in time, I don't think it has anything to do with the outputs or the commutators themselves, but the actual signals driving it. And the further I go back, like into the op amp, so if we get back into here, looking at this right in here, this section here, it's not a whole lot different than the other amp, but you can see those oscillations and things taking place right in here. So I'm starting to zero in on this TLO81 op amp chip as being maybe a culprit, or maybe this little FET down here. Well, I don't know if I didn't look it up. Can't tell. The symbol's really small from here if it's a JFET or a MOSFET, but it's a little FET. Something in there is causing that weird distortion of that sine wave. So there's an update where I'm at. When I get it zeroed in to what it is, I'll be back. Okay, well, we found the problem, and can't totally solve it right now at the moment, but proven that it is the problem, and I'll show you what it is here. If you look right in the middle of the image here, there's this little JFET right here, Q1. That's your muting JFET. And it's kind of strange how it works, but there's a whole network of circuitry on the power supply board that monitors a lot of the different power supplies and so forth. And anything that it sees wrong with that, it will take away the voltage at pin 9. And since this is working kind of like depletion mode, when you take away the voltage from here, this thing basically will clamp this off between 10 and 11. And you can see input ground is what they're calling that. So essentially what you're doing is you're shorting this input to ground. And by putting voltage on it, you're unshorting it. What was happening was this was, well, it was leaking. And I was able to prove that. Now, let's take a look at these components here, and we'll see what we're talking about. So first of all, here is a good JFET. And this is actually not the exact same component that they're using in this amp. It's one digit smaller. So the one that's in here is a 2N5458, and this one's a 2N5457. They're both out of the same family, although this one has a little bit different cutoff parameters and so forth. So even though it will partially function in the circuit, it won't work properly, and it will cause the amp to partially mute, or it won't work right. But they both will read almost identical in the tester. So let's take this good one. This is a brand new Fairchild Electronics, and we hit this, and you can see it reads very clearly as an N-channel JFET, and it gives you the pin out and so forth. If we then move to, here's the one, hold on a second. Here's the one that I removed from the amplifier, and I'll just put it in here just the same way and turn it on. and you can see it just reads like a diode. It's bad. This is a faulty component. The funny thing is, it reads faulty in here, but if you put it in circuit, it partially works. One side of it obviously is going into depletion, is going into depletion. The other side is not, and that's what's causing the funky looking waveform. So essentially, we could probably just totally remove that from the circuit to test this out, although there won't be any type of muting or any type of safety to shut this down if anything happens. So of course you would never want to do that. But I do not have a 2N5458. I only have 5457s in stock. So I'll have to order some of the correct components. I looked to see if I even had some RCA or NTE equivalents, but I do not. It's one thing I don't have. So I'll have to order some of those, which they're very inexpensive. They're only about 60 or 75 cents a piece. So that's a cheap fix. But I did prove that I did put a 5457 in there temporarily, and until it clamped back off, it worked absolutely perfectly. It fixed it. So that is definitely our problem. That's all it is. It just takes a lot of, again, you have to kind of look at the waveforms and follow the problem back in the circuit until you get to that point. And the way I was able to eventually prove it was, if you look at this input resistor right here, you can see I have two oscilloscope probes connected to it, and that represents this. Let me zoom you in. This represents this point right here. So I put one probe on this side of the 15K resistor and one on this. Since this resistor is such high impedance, it's not going to have much effect to the signal on this side, but it will on this side. So technically what you should see is the full strength signal on this side and then just a slightly attenuated one on this side because of that 15K. It shouldn't be really attenuated very much though. What I was seeing was a perfect signal on this side and a badly distorted one on this side, which is what led me to believe that there must be something going on with this JFET, because you have this capacitor isolating the rest of this circuit, so you know that the problem can't be up here if you can see it beyond this capacitor. So that's kind of what I did and kind of how I approached the troubleshooting of this, and that ended up being the problem. Okay, so this is kind of a no-no, but I've removed that JFET altogether from the circuit, and therefore this has no means of muting itself if something goes wrong. So this is something, I have all kinds of test equipment connected and everything. This is not something you would ever do under normal circumstances. I'm connected to a dummy load, but anyways, I just want to show you how everything works now with that JFET out of the circuit. So essentially, that JFET is no longer influencing the input signal to our op amp and to our driver circuitry. So you're looking at across the 8 ohm dummy load. I'm only putting a 0.5 volt RMS into the amplifier, so we'll start it out at low watts. And you can see we have a really nice little sine wave. It's bouncing around right now because it's not syncing up. Now I will go to 1.5 volts. So we're going to add 1 volt. And you can see beautiful waveform. And that's running probably, it's running at -5 dB to 525 watts. Then we're going to go to 2.5 volts, and this is going to give us full power. And this is right at about 525 watts. And you can see clean as can be. And totally undistorted waveform. That's how it should be. Now I'm going to go and I'm just going to bump this up 0.2 of a volt. And I'm going to show you how it clips now. And you can see perfect symmetrical clipping. And and that's just right above right around the 600 watt stage. It starts to do that. So there you go. That's all that was really wrong with this amp. other than needing an alignment done to it. So we're going to have to get one of those JFETs, and we're going to have to replace it, and this thing will be up and ready to go. And then as soon as we do that, we're going to do a modification to the light circuit. Just a little side note on that. If you remember, hold on a second. So if you remember, we had this board out, and it has that big 10 watt 330 ohm resistor. You have those two Zener diodes and these bulbs. And I said, you know, it's so hot it actually scorched the housing of the meter on the back. And I said, I'm not sure why that's in there. Well, I think I have a little understanding why they did that. And I believe the reason that big resistor is in there is to just give a balance to the positive and negative 31 volts. So by having that load distributed across them, it's going to ensure that both of those rails are exactly the same charge. Now, I would think a better way of doing that would have been to just use two matched resistors to ground, or something like that, and use a little bit lower value. You don't need to draw that much current, I wouldn't say, for equalization of the capacitors. And then just use a very simple resistor or capacitor dropper with a couple of LEDs is what I'm going to probably do. So that's what this black and red wire are. This is your positive 31 volts and negative 31 volts. And chances are you would be able to not even have that balancing circuit in there, and it would pretty much track. But that is a decent idea to have those in there. So that's why they're doing it. So I'll change something around to make it a little bit simpler, and then do the LEDs, and that'll be on the next video as well. And then we'll actually do a demo of this. So there you go. I'll get this one posted, and till next time, be well, take care. All the best to all of you. Thank you all for your wonderful comments, as always. And thank you all for, I got a lot of emails on this and comments, and a lot of good, tips, go here, go there sort of things. History of Carver and so forth. So I've learned a lot myself. So, yeah. Thank you all, and till next time, be well.